Hi, hello dear friends. Welcome back to another video of Connect to Physics. If you're watching my video first time, please like, share and subscribe. As you know that we have started mission GPSTR 2021. In this YouTube channel, you are going to get complete syllabus of GPSTR in English language. So here I am going to teach you science, mathematics, biology and chemistry. Okay, all the subjects. So in that science, mathematics and physics. First we are going to cover this one. Afterwards we'll move towards to the CBZ. Clear? Chemistry and biology. Now here in today's class already I have uploaded few lectures. If you have not seen, just go and you can watch other videos. This is the 6th lecture regarding we are discussing about the physics subject. In that we are going to discuss about photodiode. Okay, in the previous class we have discussed about transistor, but in this class we are going to discuss about photodiode. See, photodiode is a very interesting and important topic. So before to move on, please I'll request you like this video, subscribe to my channel and don't forget to turn on the bell icon. Share as much as possible to all the GPSTR aspirants. It could be helpful for them. Let's move on. So in the photodiode, the 4 things you have to be remember. Okay, then you can easily understand the concept. The first important thing in photodiode, this photodiode is made up of PN junction diode. Okay, the first important thing, photodiode is made up of PN junction diode. So what do you mean by this PN junction? As you have studied in semiconductors. Okay, so P type material and N type material. So semiconductor classified into 2 types. One is intrinsic semiconductor, another one is extrinsic semiconductor. So that extrinsic semiconductor is classified into 2 types. One is P type, another one is N type. So this classification is based on doping. Okay, P and N type is based on the doping. It is classified. So in P type semiconductor you have doped trivalent impurities, and in N type semiconductor you have doped pentavalent impurities. Clear? So maybe sometimes in your examination they will ask you that in trivalent impurities added in which semiconductor, then you have to be answer for this, that is P type. Okay, in P type you have added trivalent and in N type you have added pentavalent. That's it. Now, so this photodiode is made up of PN junction diode, that you have to be remember. And the second thing, they are work under reverse bias condition. Okay, so photodiode always they work under reverse bias condition. Reverse bias condition means positive terminal of battery is connected to P region, negative terminal of battery is connected to N region. This is forward bias. So what do you mean by reverse bias? Means positive terminal of battery is connected to N region and negative terminal of battery is connected to P region. That is called as reverse bias. Okay, so as you are preparing for the teacher's post, all of you know this simple concept. Okay, so photodiode is firstly made up of PN junction diode which works under reverse bias conditioning. So see, actually here I will draw a photodiode. See, this is P type and this is N type. So in P side always majority charge carriers are holes. Okay, remember this, majority charge carriers in P type semiconductors are holes, and in N type semiconductors majority charge carriers are electrons. So in between P and N type there will be a layer. This layer you are going to call it as an depletion layer. Okay, so what you are going to call this layer in between P and type, this layer we are going to call it as an depletion layer. Depletion layer. Okay, and you can say that one more thing here I have written. Okay, so energy more than Eg here I have written. Okay, energy is more than Eg. That means that this is an electronic gap. Okay, energy gap you can say. This is the energy gap. So once the energy gap will fulfilled, that time what happen? Conduction band electron which moves to valence band electron, which is freely easily move to the conduction band. So once valence band electron moves to conduction band, then there will be a flow of electricity. You have to be remember this one. See here, what happen means, this is your positive terminal and this is your negative terminal. Okay, this is the photodiode, this is p type and this is n type. So it is work under reverse bias conditioning, means, so this positive terminal of battery is connected to here in n region, negative terminal of battery is connected to p region. So this is called reverse bias. So in the reverse bias condition, what happen, so here this is electrons and this is holes. Okay, now what happen exactly means, this electron and holes, there will be a recombination pair. Okay, there will be a recombination of electron and hole that leads to a energy. So that energy we are going to get from the photodiode. Clear? So this is the thing, what exactly happened means, you have taken a PN junction diode, work under reverse bias conditioning, energy more than energy gap, and the electron hole pair generates. So if electron and hole space generate, then you can see there will be a production of current. For example, see this is, okay, this is current I. You can see here, as you are going to increase the intensity, the current is also going to increase. As you are going to increase the intensity, current increases. Okay, so this is the thing, what happen means, when you are going to increase the intensity, the current is going to increase in photodiode. Now what are the applications of photodiode? You can see, you can use applications in counting machines. Okay, in banks you are going to see, when the notes are going to count in that machine, they are going to use photodiode. And second thing, you are going to see in malls. Okay, so many malls you have visited, in the malls they are going to use photodiode. And some burglar alarms, like, they are using. So these are the applications of photodiode. So I hope you have understand the concept. Please, if you like this video, like, share and subscribe to my channel, and don't forget to turn on the bell icon. Thank you, dear friends.